Hey Pre-Calc students, today we're going to be doing Infinity Lab, Module 2, Steps 1 through 3. And what we're going to be doing is graphing rectangular coordinates and polar coordinates, and then we're going to learn how to convert between the two. So the first step, Steps 1 and 2, is really easy. You just have, if you kind of see it here, a complex plane. And on the x-axis you have real numbers, the real parts, and on the y-axis the imaginary numbers, the ones with I. And so remember, our complex number is in this form. Remember, it's z is the complex number, a plus bi. And again, a is the real part that we can graph along the x-axis, and b is the y part, basically, that we can graph along the imaginary axis. So we're just going to graph a couple of different points. I'm going to graph on this one on the worksheet 5i and 2 minus 3i. So if we look at 5i, really 5i here can be represented by 0 as the real part, so 0 plus 5i. So I don't go right or left when I graph this, I just go up 5, okay? It's just like graphing the point, the rectangular coordinate 0, 5. So you're starting in the middle, okay? And then you go up 1, 2, 3, 4, 5. And so that right there is 5i, okay? Nice and easy. The next one is 2 minus 3i. So again, you can see that it has, for this point, it has a real value of 2 and an imaginary value, imaginary part, negative 3i. So I'm going to graph it like 2 and negative 3. Okay? So I just go, starting from the center, I go over 2 and down 1, 2, 3. So there's that one, 2 minus 3i. Okay, so that's really all for that first part. The second part, they give you polar coordinates. Now, polar coordinates, they give it to you in this form, r comma theta. There is a more complicated way of looking at it, but we're just going to look at this for now, and then I'll show you something later when we convert between the two. So they're telling you what the radius is, and they're telling you the degrees. Okay, and what we're going to do is we're just going to use a ruler to find this. I'll do number 1 and I'm going to do number 5. So on this one, 3 is the radius or the modulus, if you remember that. And I'll just write this up here. This is the polar. So r comma theta. So those are the two there. So again, we have 30 degrees, so what I want to do is I want to take my protractor here. I'm going to find 30 degrees first and mark that to give me a reference point, and then I'm going to figure out how to do my radius. So here's 30 degrees, so looking here, starting at the x-axis, I go up to 30. You can see it, the lower number is 30, and I just put a mark there. So now I have an idea of where I want this thing to be, so I'm just going to put like a kind of a light dash line through there, okay? So I know that this right here is 30 degrees. That's my theta. Again, it's 30 degrees. And what I have to do is now figure out how I'm going to do 3 as my radius. So I'm going to look at these right here to help me like figure out how long is each unit. And I can see here it's 6 little millimeters. Okay, it's 6 little tick marks on here. All right. So if I look at that again, these are actually centimeters, these bigger numbers, but these are millimeters right here. So it's 6 of these. So I'm going to use that as my guide. So what's 3 times 6? That's 18. So I need 18 of these little units, and then I'll mark that off. So again, each one of these represents, I'm trying to like put it on the line here, each one of these represents, each one of these centimeters is 10. So I know if I go over here, that's 18 of those. So right there, that's where I want it. Okay? So that right there, that's my complex number there, or that's really in polar form here. So this represents, like we said, 3, 30 degrees. All right, so now I'm going to do another one. So just remember that on your ruler, each unit is represented by 6 millimeters, 6 little tick marks. So now I'm going to do a little bit harder one. So something that's greater than 180 degrees. So on this one, 2 and 225. So 2 is going to be my radius, and 225 is my angle. So if I look, again, using my protractor, I know that from here, starting at the 0 here, I can go all the way around and get 180. I need 225. So what's the difference between 225 and 180? So I'll just do that over here. 225 minus 180. What's that difference? Well, it's actually 45 degrees more. So I need to add another 45 degrees over here. Okay? So what I'll do, I know you'd probably do this as well, is I turn this over, and I know it's going to be over here. So I'm just going to add another 45 degrees over here. So here's 0, there's 45 degrees right there. Okay, it's right in the middle of the 40 and the 50. I just put a little mark there. Okay, I'm going to turn it back around. So now I know that along this line right here, okay, along that line, that's 225 degrees, okay? From here all the way around to there. That's 225, okay? So now I just need to figure out what the length would be. And we know it's 2. And again, think, okay, each one of these units represents 6 tick marks on here. These little tiny tick marks. What's 6 times 2? It's 12. So I know that my line has to be 12 tick marks long. So I'm just going to go out to the 12, and I'm going to draw a line from here to here. Whew, it's kind of hard. From there to there, and there is my complex number, or in polar form, really. 2 and 225. Okay, my polar coordinate there. So that's what you have to do for that second section, which is step 3. So we've graphed imaginary numbers, we've graphed polar numbers, polar coordinates, and rectangular coordinates, and then the final one here, I'm going to show you a little bit of this. So for the following complex numbers, find the modulus and theta. Now we're going to have to find it using math, algebra. So it says then graph the polar form. Okay, I'm going to do both actually just to show you. But so again, let's just do number 1. So on here, I've graphed it here, but I'll graph it on the other plane as well. So 3 plus 4i, you would go over 3 and up 4. Okay? So that's nice and easy. So we go over 3 and up 1, 2, 3, 4. So it should be up here. Okay? So that's 3 plus 4i. How would we rewrite this in polar form, and then will it match up? Will it be the same? So let's check. So on here, remember the to find r, that's the modulus. Remember that? That was the square root of a squared plus b squared. So we take the two numbers, okay? So remember our number is 3 plus 4i, where a is 3 and b is 4. So we take our two numbers a and b and we square them, and then we add those numbers together. Don't forget, if you have a negative number, maybe we can do that one next. We'll do one with the negative numbers. So I can show you how to do this again. But 3 squared is 9, 4 squared is 16, and 16 and 9 make 25, so that's why I have 25 here. Square root of 25 is 5, so I know my radius should be 5. And remember, if each little tick mark is 6, or if each unit is 6 tick marks, then 5 times 6, that should be about 30 tick marks using my ruler. So we'll just check that, making sure that's right. And then to find our angle theta that we need, basically it's important to draw this out and maybe just draw that rectangle and show the sides. You went over to the right 3 and up 4. So if you label that, it should help you. And remember, tangent is what we want to use. So if we think of tangent, here's theta. Tangent is opposite, it's 4, over the adjacent side, which is 3. And then to find the angle itself, we have to take the inverse tangent. So that's what this is up here. Take the inverse tangent of 4 over 3. And if you look over here, you can do it the way they've written it out here. The inverse tangent of B, that's 4, over A, that's 3. So if we do that, okay, so using my calculator, inverse tangent of 4 over 3 ends up being about 53 degrees. So now I should measure out 53 degrees, and it should be about 30 tick marks. And so, but if I were to write this in polar form, it would be, remember, the radius, comma, and then theta. So that's really the polar form right there. It's one way of writing it. And again, on my graph over here, I should be able to measure this out. And it should be about, it's going to be approximate, but it should be about right. So, and look at that, 50, and then 53 degrees. It's really hard to see, but it should be like right here. And look, there's my line right there. That is right along that line, okay? So 53 degrees, that's correct. We got that part. And now we just have to measure out, remember, 30 tick marks. So 30 tick marks will be about 3 centimeters on here. So you can see it's really close, right there. So that's 30 tick marks. Because remember, each one of these represents 10. So yeah, 30 tick marks. There it is, right there. So we just confirmed that that's the same. So that's good. And again, this is 53 degrees. So it's 3 plus 4i, or in polar form, 5, 53 degrees. So those are the same number there. Just one's written in rectangular, one's written in polar. Last one. Let's do one where you have a negative of some kind. So let's do number 5 again. That's a good one. So on here, I'm going to just draw this. And remember, it's nice and easy to do the rectangular form just because, that's the way we've always learned it. So if I go left 2 and then I go down 1, 2, 3, 4, 5, I'm over here. I'm going to do that as well. So that's a -2 and a -5, really. I'm going to have my triangle kind of situated like that. All right. This will be the angle we're looking for all the way around. But we're going to use this angle to find our answer. Okay, so all the way around is the angle we actually need. We need it to start at 0 degrees and go to where that radius is, okay? But we're going to actually use this angle right here to find what this angle here is, okay? So, so let's graph that on here again. So -2 and then -5. 1, 2, 3, 4, 5. So there's -2 minus 5i. And again, we're trying to find this angle all the way around. So let's start by finding the modulus first. So modulus R equals, and this is what I wanted to show you. You've got negatives here. Don't forget, put those in parentheses and then square them. So this is -2 in parentheses squared plus, always a plus in this formula, -5 in parentheses squared. Okay, so really what we have is -2 squared. That's -2 times -2. That's a +4. -5 times -5 is a +25. And now if we combine those together in the square root, we get the square root of 29. We can't really do anything with that, so we're just going to have to leave it like that. So that's our modulus. But if we want to know approximately what that is, just so we can actually graph it on the plane, it's 5.4-ish. It's about 5.4. And I'm going to do, again, remember each one of these things represents 6 tick marks. So I'm going to do 5.4 times 6 to get how many tick marks I need. So I need about 32 tick marks. Okay, I need about 32. So that's going to be my length there. And now I'm going to have to find theta as well. So tangent, we're going to start doing tangent of theta. And again, this is really the theta I'm talking about, but we're looking for this angle out here, okay? So this little angle here is theta, and then we can call this something else. The angle we're looking for, maybe we can call it beta or something like that. So we'll call this beta. That's a B, but it has like a fancy B. So that's what we're going to actually try to find. So tangent of our triangle here, looking at our triangle, we would have to go opposite, so that's -5, opposite over adjacent, which is -2. And again, what you have to do is take the inverse tangent of that ratio, -5 over -2, which really is just 5 over 2. So I'm just going to do the inverse tangent of 5 over 2. I get 68 degrees approximately. Now remember, that's not our final answer because it's just saying right here that this right here is 68 degrees. But I know that beta is 180 degrees plus that. I have to go around 180 degrees and then add on that 68 degrees. So we'll say beta, what we're looking for, is 180 plus 68, okay? And that ends up being 248. So now I know my angle, and I know, again, my radius is 5.4. My angle is 248 degrees. So that right there is my answer in polar form. And finally, just check it. So remember, 32 tick marks, and we're going to just add on, I'm going to just do this right here. I'm turning it over. I'm going to add on 68 degrees. So there's my 68, and look, that's right where I have that marked along this line, right? That's where I have it marked. So along this line, and then we're going to just make sure that it is 32 tick marks as well. So a little bit off again. So we might have it might have been something minor that we did because 32 tick marks is right here. It's more like 35 or 34. Okay, so if I were to be exact, let's try 5.4 times 6 and see if that's even closer. It's still only 32.4, but again, it just could be a minor error, but it's basically like right in there. Okay, so that is what you guys will have to do today.